Hello and welcome to this video on finding the surface area of cones. In this video we are going to go ahead and look at cones and calculate the surface area. Okay, and we're going to go ahead and start off with your prior knowledge on first finding the area of a circle, because we know that a cone, right, has a circular base, and it comes to a point, right, or an apex. So we're asked here to find the area of a circle, and they say round to the nearest tenth. Well, in order to calculate the area of a circle, you need to know the formula, right, and the area of a circle is pi r squared. So thus the natural question is, okay, well, what is the radius of this circle? Well, here they give us the diameter, and that is the whole distance across, right, the circle. Okay, so half of that would be 3 centimeters. Okay, so I have the radius. All right, well, since I have the radius, now it's just a simple calculation. Pi times 3 centimeters quantity squared gives us 9 pi centimeters squared. Now, this is known as an exact solution. 9 pi centimeters squared. Here they tell us to round to the nearest tenth. So what I'm going to go ahead and do is plug it into my calculator, 9 times pi, and I get approximately, not equals, I get approximately 28.27, well, they want to go to the nearest tenth, so it's going to be 28.3 centimeters squared. Okay, and there you have it. Just important note, don't multiply by 3.14, multiply by the actual pi function inside your calculator. Okay, something else we're going to have to do with cones is we're going to have to calculate what's called slant height, and this can be represented by a right triangle. So here we're asked to find the missing side of a right triangle. And what do you know? The missing side is the hypotenuse over here, right? And I'll just use the variable c. That makes lots of sense. And they say, okay, round to the nearest tenth of a foot. And here, sometimes these problems can get kind of tricky. They'll switch up conversions on you. And if you notice here, this side is 36 inches, and on this side, it is 6 feet. So I have a discrepancy or a difference in units. Well, I need them to have the same type of units when I'm going to do calculations. So what do I want to change? Do I want to change inches? Do I want to change feet? Well, what does the problem want? They want you to calculate the side to the nearest tenth of a foot. So it would make sense, right, that I change this 36 inches, right, into feet. So 36 inches, and I want to convert to feet. Okay, I want to get rid of inches. So what's the conversion rate between feet and inches? Well, 1 foot is 12 inches, right? And this is my chemistry coming in handy. I wasn't the best chemistry student, right? Inches cancel. See, I'm already messing up. And then I have feet. So 36 feet over 12, which is 3 feet. And I know that's a simple conversion, but that's kind of how it's done, right? And I know a lot of us struggle with conversion. That's why I married a science teacher. That way, if my daughter has any questions, I just say, hey, go ask your mom. Okay, so we want to go ahead and find that side. Well, we know that the Pythagorean theorem can help us out, find the missing side of a right triangle. A squared plus b squared equals c squared. So we have 3 squared plus 6 squared is going to equal 6 squared. So this is 9 plus 36 is equal to c squared. So 45 is c squared, which means that this is the square root of 45 feet, which if I punch this in, nearest tenth of a foot would be approximately 6.7 feet. Okay, so there you have it. All right, so let's go ahead and look at the net of a cone. The surface area of a cone is equal to the sum of the area of the sector, or what is also known as, I want you to highlight this word sector here. We generally don't call it a sector, we call it lateral area. So the lateral area, and that is the area that goes around the cone. And if we're talking about something like party hats, right, that's the material on the outside, and then we're going to add that lateral area to the circular base. Okay, so here is what the net of a cone looks like, and that's what we have to calculate the area of. Okay, so it would make sense, right? If I want the formula, well, I need to know what is the area of a circle. Well, we know that that is pi r squared. Okay, and then I need to know, how do I calculate this area here of this sector, or the lateral area? And that formula is pi r L. Now, what the heck is L? Well, L is your slant height, and this is probably in the next slide. L is equal to slant height, right? And slant height is this distance here. It's from the apex to the base. That is your slant height, okay? And it's just like a cursive L. So we're going to find the radius of a circle. That's always important. We need to know what is the slant height of the cone, and then we're done, right? Because here is our formula. S is equal to pi RL plus pi r squared. And that's our formula that we're going to be using for the surface area of a cone. All right, so let's go ahead and look at a problem and solve for it. So here we have a cone, and they say find the surface area of the cone. And okay, so again, like I've been preaching, first it's important to know, okay, what is the object? And obviously they tell us, right, this is a cone. So I need the formula for a cone, right? And that is S is equal to pi r L plus pi r squared. Okay, so again, the first thing that we're going to need to find is we need to find what is our radius. And you can say that that's step one. What is the radius? And here, right, from the center of our circular base out to the edge, that is 12 centimeters. So that was very, very easy. Step two is, what is the slant height? And the slant height is indicated here, okay? And I don't know what it is. So what we're going to have to do is we're going to have to use the information given. And generally with these problems is you will see an embedded right triangle. So I have the pure height of the cone, right, from the center of the base to the apex. That is 16 centimeters. And I have the radius, which is 12 centimeters. So thus, I can use the Pythagorean theorem. 12 squared plus 16 squared is equal to L squared. Okay, so I'll go ahead and utilize my calculator. 12 squared plus 16 squared. That gives us 400 is equal to L, and the square root of 400 is 20. So L is equal to 20 centimeters. Okay, so 20 centimeters. All right. Okay, so step three is just go ahead and utilize the formula that is given. So S is equal to pi times the radius. So this is 12 centimeters times the lateral height, which is 20 centimeters, plus pi times the radius squared. So 12 centimeters squared. Now, it's very, very important first. You want to execute your calculations, and you want to keep it in terms of pi. So what we have here is 12 times 20 is going to go ahead and give us 240 pi centimeters squared, plus 12 squared is 144 pi centimeters squared. Okay, so this gives us 384 pi square centimeters. Okay, this is what is known as exact. Boop. Okay, and it is in terms of pi. in terms of pi. So you always want to have your pi first. I got this from Miss Figueroa. You always want to have your pi first, then you want to eat it. Okay, so now what we're going to go ahead and do is we're going to use our calculator and we're going to multiply in the exact value of pi. So 384 times pi gives us, and what do they want us to round to? They don't say. The nearest tenth will be fine, I'm assuming. 1,206.4 square centimeters. Always check the problem, make sure where do they want you to round to. If they don't specify, 3 digits is always the safest, but here I think in the 10th you're going to be fine. Okay, so 1,206.4 square centimeters is the surface area of this cone. Okay, next example. Find the surface area of the cone. All right, well, I know that surface area is equal to pi RL plus pi r squared. So I need to know, step 1, what is the radius? Okay, so here they give us the diameter. They're trying to be tricky. They say 16 centimeters, but it's all the way across. So what's half of that? 8 inches. Okay, so there's your radius. Now what we need to know is what is our lateral area? What is this distance here? Okay, so note they do give you a right triangle. If you take half of this, right, here's our radius, that's 8, and they say the height is 15. Okay, so we can go ahead and use Pythagorean theorem. Actually, I'll use L. So 8 squared plus 15 squared is equal to L squared. So $289 is equal to L squared, and the square root of 289 is 17. Right, and if you're confused about what I'm doing here, I'm just taking the square root right of both sides. So okay, my lateral area or lateral height is 17. Okay, so step 3, all we're gonna go ahead and do, right, is plug these into our formula. S is equal to pi RL plus pi r squared. Okay, so I plug this in, pi times the radius, 8 inches, times the lateral height, which is 17 inches, plus pi times the radius squared, 8 inches squared. Okay, so I'll multiply 8 and 17, which will give us 136 pi square inches plus 64 pi square inches. Okay, and we can add those together, and we get 200 pi inches squared. Again, this is your exact answer, right? In terms of pi, we have our pi. Now we can go ahead and eat it. And actually, I'm going to use approximately. So 200 times pi gives us 628.3 square inches. And this is approximate. Okay, so I know in class we would tell you make sure you have both answers. Sometimes they'll say give the exact solution, give the approximate solution. If you do both, we can grade you for both, okay? But if they want the approximate and you stop at the exact, we can't give you credit. If they want the exact and you only give the approximate, then we can't give you credit for that. So show both, okay? All right. Let's go ahead. The next couple of examples are just finding the lateral surface area. And so these problems really, we've kind of already done these. Very, very simple. You just want to find the lateral surface area part, which of the formula, S is equal to pi RL plus pi r squared. This is the base right here. Okay, so we don't need this. We can cross this out. Okay, so for lateral surface area, all we need is pi RL. So really, the steps are the same. Okay, what is the radius? Okay, well, they say the diameter, again, that's the diameter. So half of that would be 7 inches. Okay, next step. What is the slant height? L is equal to, well, it's not given. So we're going to have to go ahead and again use the Pythagorean theorem. And I like drawing just a right triangle. That's the slant height, L. I know that this is 7 and this is 8.5. So thus, 7 squared plus 8.5 squared is equal to L squared. Okay, and I'll go ahead and calculate that. 7 squared plus 8.5 squared. And this gives us L is approximately 11.011. We'll just go with approximately 11 inches. Okay, so 11 inches. And then now we can go ahead and calculate. So S is equal to pi, the radius, times the slant height. So pi times 7 inches times 11 inches, which gives us 77 pi square inches. Okay, and again, there's our exact answer. And now we want our approximate answer. So 241.9 square inches. Okay, and there's your answer. All right, very last example. Here we have a tent, and they say find the lateral surface area of this tent. Okay, and again, the problem has not changed. We know that S is equal to pi RL, right? That's our slant height. So I need to know, okay, what's the radius? Well, the diameter is 9 feet, so what's half of 9? 4.5. Okay, and then I need to know what is the slant height. Hey, here they're kind. They tell us the slant height right away. They say it's 15 feet. So thus, I know that the lateral area is pi RL. So pi times 4.5 feet times 15 feet is equal to 67.5 times pi square feet. Okay, there's your exact answer. Now go ahead and multiply in pi, and you get 212.1 square feet. And there you have it. All right, I hope you by now know how to calculate the surface area of a cone, as well as the lateral area of a cone using the formula S equals pi RL plus pi r squared. And then also I do have a practice problem here for you. I want you to find the lateral area of the roof. Say you wanted to buy roofing materials, what would be the lateral surface area? Okay, so go ahead, pause the video, try this one, and I'll show you the answer here in a second. Okay, hopefully you had paused this and tried it. You need to go ahead and calculate the radius, right? The radius is half of the diameter, so 3 feet, and then they're kind. They give you the slant height, right? Normally they give you the pure height from the apex to the center of the base. So this one should have been easy, and the answer is approximately 113 square feet. All right, that is it for this video. I'll catch you next time. Peace.